Yes, good evening, everyone. Am I audible? Please let me know in the chat box. Yes, good evening, everyone. Am I audible? Please let me know in the chat box. Hello, am I audible? Okay, I hope I'm audible. So let's start with this particular session. Let me share my screen. So today also we will spend some time solving problems on KMAPS, and we will wind up this problem solving session on KMAP in this, if possible, in this particular session, right? Okay. Fine. So this is your first problem where a particular K-map for a Boolean expression is given, and we need to find the simplified expression which we are going to get from here. So this is the question. So you can take your time and try to answer this, right? So the K-map for a Boolean function is shown below. The function is it's a simple question. You can take your time and try this out. So let's see who can do this. Your time starts now. So you can take 5 minutes of time and you can do this. Okay. Let me share my screen. Sorry. One second. Let me reshare my screen. Yes. So this is the first question for today, where you need to solve this particular key map and you need to come up with a solution. It's a very simple question. Please try this out and let me know in the chat box. So you can take 5 minutes of time for solving this particular question. Okay, I will also solving this particular question parallelly. So let's see how to come up with this particular solution. So let me draw the K map over here. Okay, I'll solve here only. Okay, whether it is in SOP format or POS format of representation. Whether this particular expression is represented in SOP format of representation or POS format of representation. The final solution. Hello, am I audible? Yeah. So this is basically represented in SOP or POS form of representation. The final solution. So it's basically represented in POS form of representation, right? My final solution is represented in POS form of representation. So I can basically consider max terms for solving this particular question. Please take your time and solve this. So we need to take max terms for solving this particular solution. I will also enable the clock for this particular question. Let's Yes. So try to solve it and let me know the solution. What is the option which we are going to get for this problem? Option B. Okay, I got one answer. Let's wait for 30 more seconds and let's see the answers from other people also. Okay, let me do it parallelly. So this is, let me disable the, right? So this is Marx terms, right? So I'm going to consider it as y plus z. It is y plus z complement, and it is y complement plus z complement, and y complement plus z. And this is w complement plus x complement, and this is w plus, sorry, this is w plus x, and this is w plus x complement, and w plus w complement plus x complement, and w complement plus x. This is what we are going to get. Now, I'm going to take over here max terms, that is zeros I'm going to consider since my final solution is in POS form of representation, right? So I'm going to take 0, 0, 0, 0, 0, 0, and 0. So this will make a quad for me, and all the four corners are one more quad, right? So over here, what is my final solution? It will be, it is nothing but x plus z into w complement plus y. This is what I'm going to get. If I'm going to take common the four corners and this particular quad, which is nothing but option B. Exactly. Correct. Everyone getting the same answer? Any different answers? Anyone getting? Okay, I can see only one answer. Others also try to solve it and let me know. Okay. Yes. Now, let's see the next question. So a function with Donkey conditions is as follows. So we have given with minterms, which is 0, 2, 3, 5, 7, 8, 9, 10, 11, and we are also given with don't cares. Now we need to find out the minimized expression for this particular function. What is the minimized expression which we can possible for this particular function is the question. So take your time. So your time starts now. You can consider this timer, 3 minutes timer, and try to solve it. So here we are given with min terms and we need to find out the minimized expression and we need to verify which particular option we are going to get after minimizing this particular KMAP. I hope the question is visible, right, for everyone? So a particular function with don't care conditions is given. Uh, we are given with min terms and don't cares. So we need to find out the minimized expression for this particular function. Okay, I got one answer. It's option B. Okay, I got two answers. Great. Option B. You have we have 1 more minute. Please try to solve it and let me know. I want answers from others also. Please try it out. So remaining last 20 seconds. Let's see what's the answer you're going to get. Okay, let me draw the KMAP quickly. So hmm, option B. Okay, great. So let me draw the KMAP for this and let's see what is the options we are going to get. So I'm going to have this KMAP, which is a four variable KMAP, which is going to have 16 number of cells like this, right? And this is AB and CD. C complement, D complement, C complement, D, CD, CD complement, and A bar, B bar, A bar, B, AB, and AB bar. So 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, and 11, 10, 12, 13, 15, and 14. So I have the midterms at 0, 2, 3, 5, 3 and 5, 7, 8, 9, 10, and 11. And don't case at 4 and 15. 4 and 15. So these are my don't case. Okay. Anyone getting apart from this? Okay, I can see all the three answers as B. Okay, let's see what is the answer we are going to get over here. So I can basically make a quad over here. So this is one quad which I can form, and what else remaining? I can form one more quad using this cells. This is one more quad, and I can form a quad over here, and what else I can do? I can form a dual and form a single like this, right? So these are the possible groupings which I do have, right? And any other possible groupings we can see over here. So this is one quad, and yeah, this is what I'm going to follow over here. So what is that my equation I'm going to get? So this dual is nothing but A complement. Here A complement is common and C complement A bar C bar plus over here it is A B bar, sorry, A complement is common over here and C bar D bar. A bar C bar D bar plus AB complement is common and plus CD plus this last two, what is the common part over here? B bar and what is common in this two here we have B bar common and here we have C common. B bar C plus in this two we have A bar B and the common part over here is B. So this is what I'm going to get. A bar BD, A bar BD plus B bar C, A bar BD plus B bar C plus okay, I cannot see this. A bar BD is not there now. This option is not there actually. Option D. Okay, I got one more answer as above all. Okay. So where is this option? B bar, C bar is not at all there. Where I got this term from. B bar is common, and sorry, B bar C. B bar C is not. B bar C is there, and A bar B D is there, and A B bar is there, and B bar D bar is there. Okay, B bar D bar I haven't done it. Okay, basically I will get B bar D bar if I'm going to make a quad. Let one second. So let me erase it. And if I'm going to consider all the four corners, then I'm going to get B bar instead of this particular term, which I was getting, which is uh, A bar C bar D. Instead of this term, I'm going to get what I'm going to get. The corners is B bar and D bar. B bar D bar I'm going to get. So B bar D bar, AB bar, CD plus A bar BC. Yeah, that is what I've done. Okay. So basically here there will be three possible combinations I will be going to get. Let me erase this everything and let me show you. So the answer will be all of the above. Let me show you how I'm going to get. So if I consider all these particular quads, this is one grouping and which is nothing but B bar D bar. Okay. And let's say if I'm going to group this four, which is one quad, from here I'm going to get CD. So B bar D bar plus CD I've got. And next, what I'm going to do is I'm going to make a dual of this, which will give me A bar B into D. A bar B into D I'm going to get, which is this particular term. I got this term, and this term. Next, what I'm going to do is I'm going to make this quad, which is nothing but uh, AB complement. Okay. So B complement C will be erased. So which option it is? AB complement plus B bar D bar plus CD plus A bar BD. It's option C. If I'm going to follow this particular grouping, I'm going to get option number C. Okay, anyone getting option number C? So if I'm going to follow this kind of grouping, then I'm going to get option number C. Okay. Now, if I'm going to change the grouping, let's say if I'm going to follow uh, instead of this two grouping, or else instead of this particular four group or the quad, what I'm going to do is I'm going to erase this particular quad and I'm going to have this particular quad. Then my answer will change into B bar D bar will be present, and this new term is nothing but what is the common term over here, which is B bar, and what is the common term over here, which is C, B bar C. So where is B bar C present? Uh, which is present over here. Okay, what is the answer we are going to get here? If we take common, we are going to get A A B bar plus B bar C plus here if we take, we are going to get B bar D bar plus A bar BD. This is the term which we are going to get if I'm going to make this type of grouping, right? Which is option number A bar BD, which is option number C plus B bar C plus AB bar. Okay, previously got option number A, sorry. Okay. Now, coming to option number B. So how we are going to get option number B? Let's say if I'm going to remove this, if I'm going to remove this and remove this quad, and if I'm going to have this dual and have this quad, then check it out. You are going to get option number B, which is A bar B bar plus B bar D bar plus CD plus A bar B. Okay. Is it clear for everyone? So in this particular question, we are going to get all of the above. Okay. Everyone getting all of the above? Anyone getting any different answers for this? Please let me know in the chat box. Okay, shall we move forward? Okay, great. Now, in this particular logic circuit shown below, we need to find out the redundant term. So try to find out what is the redundant gate, which particular gate is not useful over here. So you can take your time and try to solve it. So basically, we need to find out what is the redundant gate, the gate which is not useful over here. We need to find out what is the redundant gate over here. So here we need to find out what is the redundant gate in this particular logic diagram. So you have left with 1 minute 30 seconds. Let's see the answers anyone has given. Okay. Option A, B, B. Okay, fine. Still you have time. Okay, time's also up. Let's see then. Okay. First of all, how we are going to find out what is the redundant gate over here? What is the method you are going to use? Anyone wants to answer? How you got option A and how you got option B? What is the method you have used it for getting the redundant gate in this particular logic diagram? Okay, okay. So I'm going to use KMAP method for solving or for finding out what is the redundant gate over here. So for plotting it into the KMAP, first of all, I need to know it is a four variable function. I'm going to have x, y, and w and z. These are the four variables which I'm going to have. Okay. Or else I can write it down as f of w, x, y, z. These are the four variables I'm going to have. Okay. Now I need to find out the minterms over here. Okay. So how to come up with the minterms? The value of this particular function x is nothing but x y complement z plus w complement x z plus w complement y z. This is a function which I'm going to have. And from this function, can I directly consider the minterms? No, I cannot consider the minterms directly from this particular function because it's not in canonical form. So I am going to convert it into standard canonical form, and then I'm going to plot it into the KMAP, and I can basically find it out the redundant gate. Or else what I can do is I can directly plot it on my KMAP. So how I'm going to directly plot it on my KMAP by using the equation, I will show you now. So I'm going to take x, y complement z plus w bar x z plus w bar y z. This is the equation I have. So I'm going to take a K-map over here, which is a four variable K-map, 16 number of cells we are going to have. And this is, let's say we are going to take the order of my equations are x, y, w, z. So which is w bar, z bar, w bar, z, w, z, and w, z bar, x bar, y bar, x bar, y, x, y, and x, y bar, right? So this x, y bar into z, where it will be formed x, y bar. X, y bar is here, and I want z. Z is common in this two terms. So I can write down 1 in this particular two terms. So like this, by seeing the equation, I can write it down. So x, y bar is common in this all cells, and z is common in this only two cells. So I'm going to write down the minterm over here in this two cells. Or else what you can do is you can convert it into standard form, and you can basically plot it in your KMAP. That also you can do it. Okay. Now, next is W bar XZ. W bar XZ. So, where is first of all, XZ, X is common in this two. So, X is common in this two, and Z is and we need W bar XZ. So, W bar is common over here. W bar X and Z. So, Z is present over here, and W bar we are going to get here over here W bar Z and X. That means this two terms. So W bar Z and X we are going to get. So that means this two midterms. Next W bar YZ. So W bar is present over here, and we want Y. So in these two cells we are going to get Y. So that is nothing but W bar, and if we take, then x is not common, but y is common, and w bar yz is common over here. These are the minterms I'm going to get. So if you're not aware of how to write down the minterms by directly saying the equation, you can just follow. You can basically convert it into standard form, and you can solve it. Okay. Now what you're going to do, I can plot this two, and I can plot this two. These are my essential prime implicants. This is one essential prime implicant, and this is one more essential prime implicant. What is the redundant prime implicant we have? This is the redundant prime implicant. And its value is nothing but x into w bar z, which is nothing but w bar xz is a redundant prime implicant, which is w bar xz is nothing but my second gate. Okay, so my option is B. Okay, this is written because you can see over here, this grouping is not necessary, but you are going to do. It's nothing but RPA, which value is nothing but W bar XZ. Okay, just to be sure about the order. That's it. Here the order is W first and followed by XZ. So if you rearrange it, you are going to get the equation. Just how done it. So this is nothing but my W bar XZ. Is it clear for everyone? How we are going to find out the redundant terms? If you're not aware of how to directly plot the minterms from the equation, you can just convert it into standard form, and you can plot the minterms in your KMAP, and you can draw it. And you need to find out the RPA, and from RPA you will just get it out. Okay. Yes. Any doubts or any queries over here? Okay. One last question for you, noted for your assignment. You can basically let me know what is the solution you're going to get for this particular function f of a, b, c, d, which is given with the max terms as 1, 2, 3, 4, 9, 15. 1, 2, 3, 4, 9, and 15. And for this, we need to find out the minimized SOP expression. minimized SOP expression. Okay. So try to solve this and let me know the solution in our next session. In our next session also, I have some more problems related to KMAPS only. So let's try to do this problems related to KMAP and let's complete this. Okay. Yes. So the max terms here are 1, 2, 3, 4, 9, 15, and we need to find out the minimized SOP expression for this. Okay. So that's about this particular session. Thank you. If you have any doubts or any other queries, you can stay and discuss with me, or else you can leave this session. Okay. Thank you.